Topic: vapor pressure and Raoult's law. Chapter: Solution. Class 12. Subject: chemistry. In our daily life, we see many liquid mixtures such as alcohol mixed with water, petrol mixed with other hydrocarbons, perfumes, medicines, and many laboratory solutions. When liquids are mixed together, their vapor pressure changes. Understanding this behavior is very important in physical chemistry, chemical industries, and separation technique like distillation. Today, in this video, I will discuss 5 important concepts: vapor pressure of liquid solution, Raoult's law, ideal solution, non-ideal solution, and azeotropy. Number 1, vapor pressure. Number 2, Raoult's law. Number 3, ideal solution. Number 4, non-ideal solutions. Number 5, azeotropes. These are the topics of discussion today. Let us start with vapor pressure. Number 1, vapor pressure. Of liquid solution. What is definition of vapor pressure? At a constant temperature, the pressure exerted by vapor of a liquid over the surface of liquid in equilibrium state is called vapor pressure. Once again, at a constant temperature, the pressure exerted by vapor of liquid over the surface of liquid in equilibrium state is called vapor pressure. Suppose water is taken in a vessel and it is covered with some lid. It is covered. The if temperature is kept constant, whatsoever it may be, suppose it is room temperature, even at room temperature, some molecules from liquid started to escape in vapor stage, and gradually the number of molecules of vapor increases. Since the volume above the liquid is constant, so as the concentration increases in this space, after certain time, some vapor molecule touch the surface of liquid and started to condense. There are two types of processes going on. Liquid evaporates into vapor state, and now vapor also condensed into liquid state. As the space over the surface of liquid gradually saturate, as the space or the volume above the liquid surface saturated, the rate of evaporation and rate of condensation are become equal. This is equilibrium state. Equilibrium state. And in equilibrium state, whatever the vapor over the surface of liquid exert the pressure over the surface of liquid, that pressure is called vapor pressure. Therefore, it is said that at constant temperature and in equilibrium state, the pressure exerted by the vapor over the surface of liquid is called vapor pressure. Vapor pressure in solution. Vapor pressure in solution. Solution may be two type. A solution containing both component, solute and solvent, both liquid, or it may be one solute is solid and solvent is liquid. So first we are considering the two components are liquid. So now suppose two volatile liquids say liquid A and liquid B are present in a solution. Suppose vapor pressure of liquid A is, suppose, PA, and vapor pressure of liquid B is PB, then total vapor pressure of solution, let it be PT, should be equal to vapor pressure of A plus vapor pressure of B liquid. That means PT is equal to PA plus PB. Let us now discuss Raoult's law. Raoult's law for a solution containing two miscible liquids. That means Raoult's law for a solution when both components are volatile. According to Raoult's law, statement is vapor pressure partial vapor pressure of each component in a solution is directly proportional to its mole fraction. Mathematically, for component A, PA is directly proportional to XA, or PA is equal to PA naught XA. Where PA is partial vapor pressure of component A, and PA naught is vapor pressure of liquid A in its pure state at same temperature XA is mole fraction of component A in solution. Similarly, for component B in solution, we can write PB directly proportional to XB, or PB is equal to PB naught XB. As we know PT is equal to PA plus PB. So PT, we may write XA PA naught plus XB PB naught. Since XA plus XB for a solution is equal to 1, so we may write PT is equal to PA naught XA plus 1 minus XA PB naught. Raoult's law may be written for a solution for a solution containing a non-volatile solute. For example, solution of glucose in water. Glucose is solid and water is liquid. In a mixture of glucose and water, glucose will not be volatile, water is volatile. Similarly, if I am making a solution of sugar in water, sugar is non-volatile, water is volatile. So, even third example, if we are making the solution of common salt, that means NaCl in water. NaCl is non-volatile and water is volatile. In all three cases, solvent is volatile, solute is non-volatile. For that solution, Raoult's law state, what is a statement of Raoult's law? Vapor pressure of a solution containing non-volatile solute is directly proportional to mole fraction of solvent. To explain this statement, suppose a solution contains component, or better to write solute A and solvent B. According to Raoult's law, PS, that means vapor pressure of solution, is PA naught into XA, where PS is vapor pressure of solution, PA naught is vapor pressure of pure solvent A at same temperature. XA is mole fraction of solvent, So, mole fraction of solvent A. Okay. So, we understood now what is Raoult's law for two volatile component in the solution, and what is Raoult's law for a solution containing non-volatile solute. Let us discuss the ideal solution. If a question comes like this, what do you mean by ideal solution? Then we will write first definition. A solution which obeys Raoult's law, a solution which obeys Raoult's law over the entire range of concentration. Entire range of concentration. Such solution is known as ideal solution. Is ideal solution. In such solution, interaction between molecules are uniform. So conditions for ideal solution. Number one, intermolecular forces between molecules of A and between molecules of B, that is BB interaction, are almost same when these two are mixed in AB are mixed. Number two, no heat change taking place during mixing of AB. That means delta H mixing should be equal to 0. Neither heat absorb nor heat evolve. And third condition is there is no volume change. There is no volume change during mixing of two components. That means delta V mixing should also be 0. If the vapor pressure of ideal solution is if the graph between vapor pressure and mole fraction of an ideal solution is taken, then the graph should be like this. Here is mole fraction. Here component A is maximum and component B is 0, and gradually component A decreases, B increases. Here component B is maximum, A is 0. Vapor pressure increases above, means PA0 and PB0. In this direction, PB0 vapor pressure PA increases here and PV increases in this direction. And we will find that as mole decreases, vapor pressure also decreases gradually. As mole decreases, vapor pressure also decreases gradually. So, PA is graph. It is the graph of PA naught XA, and this graph is PV graph PV naught XB. Here PT graph. This one is PT graph. PT, which is equal to PA plus PV. This is for ideal solution. This is the graph of ideal solution. Now, take example of ideal solution. Examples of ideal solution. What may form ideal solution? Benzene has similar structure as that of toluene. So, when benzene mixed with toluene, there is neither heat change nor volume change, not intermolecular force of attraction change. So, similar, N-hexane plus N-heptene. This may be ideal solution. Now, let us consider non-ideal solution. Non-ideal solution. Many solutions do not follow Raoult's law. The solution which does not obey Raoult's law perfectly is a non-ideal solution. Non-ideal solution. Non-ideal solution may be two types. Non-ideal solution may be one with positive deviation, and another with negative deviation. Let us discuss one with positive deviation. Number one, positive deviation. Non-ideal solution with positive deviation. What are the example? Let me write the example first. Those in which bond between the two between the molecules of two compound increases, strength get more stronger. So if ethanol mixed with water, the force of attraction between ethanol and water on mixing decreased. Similar is case in acetone when mixed with carbon disulfide, carbon disulfide, CS2. What is positive deviation? A solution when the observed vapor pressure of solution is higher than the vapor pressure of solution predicted by Raoult's law. There is positive deviation. There is positive deviation, or it is called positive deviation. Take graph. In case of solutions having positive deviation, mole fraction XA maximum, XV minimum, XB maximum, XA minimum. Here vapor pressure graph. So what happens? The XA decreases, vapor pressure decreases, and XB, it should be like this. It should be for A, this should be the graph. For B, this should be the graph. But what happens? Vapor pressure which is observed is higher than the vapor pressure predicted. Vapor pressure predicted is broken line. Vapor pressure observed is solid line. So solid line indicates that vapor pressure expected is less, vapor pressure observed is more, or let me write here like this, but the observed vapor pressure is like this. So this one is vapor pressure of PA naught, PB naught, PA naught, XA. B decreases. here in this case the in case of positive deviation AB force of attraction is weaker than A or B. Number one. Number two, volume increases, mixing is higher than 0. And third, delta H, mixing is negative, is lower than 0. Let us discuss now negative deviation. Negative deviation. In case of negative deviation, what happens when the observed vapor pressure of solution is less than vapor pressure predicted by Raoult's law. It is called negative deviation. Negative deviation. What are the examples? Examples are: number one, acetone mixed with chloroform, or nitric acid mixed with water. In all these cases, in negative deviation, volume decreases, force is stronger than AA or BB. Point 1, volume of mixing decreases. And point 3, delta H, mixing is greater than 0. Heat released. So, what should be the graph? Its graph is like this. In negative deviation, mole fraction X B1, XA0, XA1, XB0. That means mole of A decreasing and mole of B increasing. So what will be the case of vapor pressure? Vapor pressure, as mole decreases, vapor pressure also decreases. So for graph B, for component B, graph will be like this. this, but it should be expected. It should be expected graph. And what should be the actual graph? Actual graph should be lower than the expected. Similarly, for A, it should be maximum here and it should decreases. But the actual graph should be like this. So here is PB naught, here is PA naught, and this one is graph of PA, which is equal to XA, and this should be the graph of XB, PB, XB. So this is the negative deviation. Let us define azeotropy. Azeotropy. What do you mean by azeotrope? Or if the question is asked, define azeotrope. A very interesting phenomena related to vapor pressure is the formation of azeotrope. What should it be? The definition is an azeotrope is a mixture of two liquids that boil at a constant temperature and has the same composition in liquid as well as in vapor state phase. It means definition may also be written like this: a mixture of two liquids that boil at a particular temperature and has the same composition in liquid and in vapor state is known as azeotrope. Azeotrope cannot be separated. Azeotrope separated by simple distillation. There are two types of azeotropic mixture. There are two types of azeotropes. Number one, minimum boiling azeotrope. Minimum boiling azeotrope. Such azeotrope or such two liquid mixture which has positive deviation. This mixture boils at a temperature lower than their pure component. Let us take example. The mixture containing ethanol 5% and water 95%. This mixture is example of azeotrope. So the mixture of two liquids with positive deviation is minimum boiling azeotrope. The mixture boils at a temperature lower than the pure component. In this case, minimum boiling azeotrope boils at a temperature lower than either liquid in their pure state. This means the boiling point of ethanol 5%, water 95% mixture is much lower or must be lower than the boiling of ethanol or water. Next, second one is maximum boiling azeotrope. The liquid mixture which shows negative deviation. This occurs when negative deviation is present. This occur when negative deviation is present. That means when force of attraction on mixing the two liquid becomes higher, then there will be maximum boiling azeotrope. Example is, take example nitric acid plus water. Maximum boiling temperature both liquids. The mixture, this mixture boils at higher temperature than two, then both pure liquids. Now come to the conclusion. Today we have discussed vapor pressure of the liquid, second Raoult's law in both cases, two miscible liquid and the solution containing non-volatile solute. We also discuss ideal solution, non-ideal solution, positive deviation of ideal solution, negative deviation of ideal solution, and finally azeotropes. What are azeotropes? Understanding these concepts is very important for distillation process, chemical industry, etc. In next video, I shall discuss colligative property and relative lowering of vapor pressure. Thank you.